up, students? This is Dr. Smith here to talk to you today about fractions. We're going to get started on fractions. I'm going to start from the very beginning. If you feel that you have a decent handle on fractions, just stay with me because I want to make sure that if we have a few people that have a phobia of fractions, meaning that they're a little bit afraid of them, or you start talking about fractions, they tend to fall asleep, or they want to leave the room running and screaming. We're going to start from the beginning so that you can get rid of that phobia, hopefully. Okay? So, fractions. Fractions have two numbers. So, let's say we have this number, which is considered 1/2. How fractions are set up is they have a number on top and a number on bottom. The number at the top is the numerator. The number on the bottom is the denominator. Get comfortable with that vocabulary because you never know when your teacher starts using these words. You want to know what she's talking about or he's talking about, because there's some people who said the what. So numerator, denominator, get that in your head and try to use those words. So how we represent this with the picture, I'm going to use a circle first. So the top number, let's start with the bottom number, the denominator. The denominator is the number of parts you have in all. Trying to use simple terms here when talking about it. So we have two parts, two parts. The numerator is, in this case, it's going to be the number of shaded or colored parts. So we'll talk later how this number can change. It might not be the shaded part, depending on the question that they ask you. It could be the non-shaded part. So we'll get to that as we go on. So we need to shade how many parts? One part. So this is how you show a picture that equals 1/2. That's how a fraction is set up. Now there's other ways you may see it. Your teacher may do it this way. For those of you who've seen my video that talks about area and perimeter, you know, this is kind of like how we talked about area and perimeter. You're going to have to know the sides and the length and the width. Well, you can divide that up this way. So you still have two parts, and we can shade one part. So you can decide how you'd like to represent the fraction. So if we have 1/4, I'll put this here so it's not confusing. If we do 1/4 as a picture, I'm going to use a circle. So let's all think about how we would represent 1/4 or 1/4. So the first thing we need at the bottom is 4 parts. I'm going to do it like this. And then we have to have a shaded part. We're going to take one of those parts and shade it. So that would be 1/4 as a picture. Now you can do that also with objects. For example, if you want to use smaller circles, instead of just the shaded part, as we talked about up here, remember I said the number of shaded parts. So let's say this becomes the number of objects in all. And here, so I'll put objects so everybody is not confused. So up here, instead of parts, you can put objects. So let's say we have 4 objects. That can represent 1/4 the denominator. In order to get the shaded object, we just have to shade one. So you can apply it to anything, pretty much. Another way you can look at this when you start doing time is this can be like a watch or a clock also, okay? Just keep that in mind. Now, the other thing you need to keep in mind is that when you have a number such as 8/8, these two numbers are the same in the numerator and the denominator. So I'm going to draw a picture before I say what I want to say about this. I'm not the best drawer, but hopefully this will look pretty decent. So we have to shade in, right here, 8 parts. That's the whole object, isn't it? That's the whole, if this was a pizza, that's the whole pizza. So think of it as a pizza. If you have 8 of the 8 slices, you have the whole pizza. So when the top and the bottom number are the same, it's one whole, okay? Just remember that. Okay, now that we've talked about the basic fraction, we're going to talk about equivalent fractions. So equivalent is just another way of saying equal fractions. All right, so if I have 1/2, we represent it 1/2 like this. Remember, the numerator, the top part, is the shaded area. The denominator, the bottom part, is the total number of parts. Well, you can make the fraction look different, but still be the same amount of the circle. So if I was to do this, we have how many parts total? 1, 2, 3, 4 parts. How many parts would we need to shade for it to look exactly like this one? That's right, 2. So this is the first part. And this is the second part. So the shaded area would be 2. You have 2 parts. Looks the same, different numbers. Right? Well, let me show you something. So if I put the 1/2 down here, and what is considered 2/4 beside it, you can use a math fact to kind of put those two together. For example, what number times 2 equals 4? 2. Can you say the same for the top? If you use this same number, would 2 times 1 equals 2? It would, right? Let me just put that in parentheses so we don't get it confused. Okay, so all this is saying is that there are twice as many parts over here. So if you divide this, or excuse me, if you times this by 2 or you double it, it'll be the same as this. You have to have double the parts for each one. That's how these relate to each other. So they look the same, but they have different numbers. Let's try another one. Remember I said you need to practice seeing fractions differently. It takes practice with math so that you don't get confused when you see different fractions. So the next fraction is 1/3. So we have 3 parts, 1, 2, 3, and we have to shade one. Numerator, 1 part shaded. Denominator, 3 parts all together. So how can we make that look differently? I'm going to cheat a little bit. I'm going to put a math fact over here. I'm going to go ahead and do that. So times some number. Let's just do 2 since we've already done 2. I'm going to put a little line here. So we're going to make it look differently. 2 times 1 is 2. 2 times 3 is 6. Now let's see if it looks the same. My drawing isn't the best, but I'm going to try to do a decent job for you. It's not going to be great, but let's see if we can get it. Just remember, mine's not drawing to scale, meaning it's not perfectly divided. I'm going to do mine a little bit more. It's a little bit better. Do they kind of look the same? I don't know. But actually, because of my drawing, it doesn't look quite the same, but the shaded area looks close to each other, though. It's a decent picture. So this is how you can compare the two. You notice that I cheated and I just went ahead and put the math fact in. You can do it the opposite way. If you have 2/6 first, you just bring them down here. You're going to see, let's see if we can come up with a math fact. I put equal. So what 1 times what will equal 2? And what number times 3 will equal 6? So you come up with the same thing. And you have to remember, these two numbers have to be the same. If you can't get both numbers, both of these numbers to go with one single number, such as 2, you can't have a 2 and a 3. You can't have a 2 and a 4. They both have to be the same. You have to do the same to the top and the bottom. And it must equal what's over here. Then that means that they are equal fractions. Okay? Okay, now we're going to compare fractions since we have a good idea of how fractions are represented. So let's say we have 3/6 and 5/6. So they would be represented well, let me put it here. We'll put the 5 over 6 over here. And we'll put the 3 over 6 over here. So 3 over here and 5 over here. Now, it's clear to see which one is the bigger fraction, because you only have one section here that's not shaded, and you have 3 sections that are not shaded here. So when you have fractions that have the same denominator or bottom number, all you have to do is look at the numerator on each one. This one's pretty easy. And the one that has the biggest number in the numerator is actually going to be the bigger fraction or the greater fraction. So what we'll do here is I'm just going to draw what I consider a little Pac-Man type mouth. You're probably too young to know about that. Pac-Man was like a little mouth that was eating up cherries and different things in a video game. But so I drew the mouth over to this side just because if you're hungry, you want the bigger amount of food, right? The greatest amount of food. So that makes this the greater fraction. So let's look at another one. So if we have 2 over 8 and 3 over 8, I know these are pretty simple. I'm not going to draw. Just look, because they have the same denominator, which is 8. This is going to make it easy. Look at the numerators, the top number, and see which one has the biggest number. And of course, 3 is bigger than 2. So we're going to have the little mouth chomp up the bigger amount, okay? That means this is the greater fraction. All right. Let's try one that's a little different. So we have 1/3 and 1/6. Now this is where it gets tricky. That's not so simple as this. So remember, the denominator, the bottom number, the bigger the number, if this was a pizza, the smaller piece you have. If you have to divide the pizza up amongst 6 people, you're going to get a smaller piece. If you have to divide it between 3 people, you get a little bit more pizza. So just to show you that, remember, I'm not the best drawer, so it's just like this. The pieces are smaller here than they are here. Somebody's going to like this piece. But just remember, when the numbers are different at the bottom, the bigger the number, the smaller your piece. Okay? So already we know that this one's going to be greater. But I'm going to go ahead and shade that one piece and the one piece here. So in this case, where you just have 1 at the top and the bigger numbers at the bottom, the smaller the number, the bigger the piece, and it's only 1 piece. So this is always going to be the bigger number, the bigger fraction. So remember to look at your picture if you need a picture just to get comfortable with this. You have the smaller number at the bottom, the pieces are bigger. More people, like over here, more pieces that you need, okay? Let's see if you can do it for the next one. So we're going to do 3 over 6 and 1 over 3. All right. So it's kind of like the one before, the denominator. Smaller pieces, of the pizza, you have to feed more people, smaller pieces. You have the smaller number at the bottom here, so the pieces will be bigger. So until you get really good at doing that, you might want to draw. You can use the perimeter or the rectangle if you need to. But here, this is going to make it a little bit more difficult, but I'm going to shade 3 pieces of the 6 pieces. And on this side, I'm going to shade 1. And which one is the greatest? Think about it. Would you want this piece or this piece? I think I would want this piece. So I'm going to do greater here. Now, if you're a little confused with this one, don't forget that we did the math facts. You can try the math fact with this one. If you want me to do it again, I will for you. Over on this side, we had 1 over 3 and 3 over 6. So if I put the equal sign here, what math fact makes something times 3 equals 6? That would be 2. Can you use the 2? Because remember, the number has to be the same up here too. Can you do the same up top? 2 times 1 equals, and that's not the same. That's actually more. That's a good way to figure it out. If that's a little confusing, you have to practice. I can stand here and do it all day, but you have to get problems and keep going through it. Go back to your system. Math is a system. Now that we've compared some fractions, I want to talk about improper fractions. This is another way that you can see a fraction. It's not going to be the normal way, such as normally, you'll see it where the denominator is bigger than the numerator, meaning the top number is smaller than the bottom. Well, when you have an improper fraction, the top number, or the numerator, can be bigger than the denominator. Okay? So, all that means when you're drawing a picture of an improper fraction, you pay attention to the denominator. That is how many pieces are going to be in your picture. So here we have 8 pieces. Now you say, well, okay, I have 8 pieces here, but it says I have 10 that are shaded. So then what you do is you come over, draw another object, and give it 8 pieces. Now you can draw the other shaded areas in that second object. So you're going to do 8 of the 8 pieces here. And now you're going to say, okay, but I have 10. So what's 10 minus 8? That equals 2. So you have 2 more pieces that you have to show over here. And because in all you have 8 pieces, you're going to automatically make it an 8. Okay? So this is how we come up with a drawing of 10 over 8. So when they say improper fraction, it just means that it has the bigger number on top unlike the normal fraction, which has the bigger number on the bottom. Okay? So I would shade all of these. Remember, when the top number, the numerator, and the bottom number, the denominator, are the same, you have a whole. So if this was a pizza, you would have the whole pizza. And then the remaining slices would come from the second pizza. Just like that. So if we were to compare this 10 over 8 to 12 over 16, in the beginning, you'll probably need to draw the picture. This is 10 over 8. This is the representation. Now, let's draw. Let's see if I can do this. I don't know if I can do this. 16 pieces. I kind of messed that up a little bit. Let's say that's 16 pieces. So this is the one that I messed up right here. It should have gone over here. So if we were to shade 12, of these pieces, it would look like this. Tell me, which one would you like? If you were hungry, would you rather have the 10 over 8 or the 12 over 16, excuse me. If I was hungry, especially if it was more than just me, I would want the 10 over 8. So that is the biggest or the greatest fraction. That's just drawing the picture. So whenever you see the numerator bigger than the denominator, you automatically have a whole. How many wholes? It just depends. But for right now, you'll have one whole with this, okay? So if you don't have a whole here, you would have to have the top and the bottom number the same. You don't have that. So there's no way that this number can be greater than this one. Okay? So what you need to do now is to do some math practice. Going over this, you can always look at this video again in different parts. To be a good mathematician takes practice. You have to know it backwards and forwards when somebody shows it to you in different ways. So have fun doing your math practice. And remember, you have to exercise your mind as well as your body. And I look forward to seeing you again and talking more about fractions.